Hello world, and welcome to Hacking Ableton Live in Lisp with Scheme for Macs. My name's Iain Duncan, and I am the author of Scheme for Macs, an open source extension that allows you to script Macs, and thus Ableton Live through Macs for Live, with S7 Scheme Lisp. And today I'm going to give you a couple of examples of what that looks like within Ableton Live. So Scheme for Macs is a Macs MSP package. You download it from the GitHub site. There's a release tab, and over here under releases, there are a zip and a tarball file. You download those and you put them into your Macs packages directory, and then you do the annoying song and dance about authorizing things from insecure developers like me to get it going. Now, assuming you've got that going, you'll have your packages directory in Macs with a Scheme for Macs package right here. And you'll see there is a folder called Examples, and that has several Ableton Live devices. And that's what we're going to take a look at today. Now, Scheme for Macs also has extensive online documentation and a very large help file. That's covered in other videos. And there is also another video on stepping through installation for people who own Macs for Live but don't own regular Macs. So you do need a Macs for Live license. You don't need to have standalone Macs. All right, so I've got a simple simple Ableton Live set, and I've got a few devices here, so I have put them on these tracks, and we'll start with the MIDI transposer. So I've got an electric piano track, and I've just put a one-note clip in there. Okay, there we go. It's playing its note. Let's turn that one up a little. And I've got the device S4M Live Transpose here. Now what I've done is I've put the guts of it in this main patch subpatcher so that gives us this floating window, which is a little easier to manage. And within that window, you can also see another message box that says Macs window. That will open the Macs console, and that's something you're going to want to have open pretty much all the time when you're working with Scheme for Macs. So we'll just clear that. And let's take a quick look at this. I won't get into in-depth explanation, but just let you know what you're looking at. So we're receiving MIDI input over here, and then we use some Macs objects to turn that into this message: note in, channel, note number, velocity. Okay? And that message is sent on to the Scheme for Macs object. The Scheme for Macs object is running the file s4m live transpose.scm, which is also in that examples directory. And then the outlets are hooked up to this MIDI format object here. So we've got channel going out the second outlet and note number and velocity going out the first. And then out our subpatch outlet, which if we look at the parent device, just goes to the standard MIDI out for a Macs for Live device. Then we also have this widget here, a number box. We're using message interpolation to call the set transpose function with the value of this number. And the way that works is the number is inserted into the message using $1, and then the message, which is a scheme call, is just sent to the S4M object. So that's one of the ways you can execute code. You can just send it these messages. So let's move that number, and you can see down in our console, the output of the function is printing to the console. We could also call that same function with the REPL here. I'm just going to call it directly. Set transpose 2. And we can see setting transpose is set to 2 over here. And if we play our music, we are now hearing transposition. Okay, so let's take a look at the code. I'm going to open the code here, S4M Live Transpose, scheme. And we'll just reset the interpreter. And so this is a very naive implementation. It's just meant to give you a starting point. It doesn't understand that if you transposed partway through a note, you would get a hung MIDI note. We're not tackling that. There's a global variable for the transpose amount. There's a function for changing that variable. And then there's a function called note in that accepts channel, note num, and velocity. And so that's what this maps to here. And in note in, we have the new note number determined from the G transpose value, and then we send out the output. All right, so let's play that again. Okay, here we go. Let's transpose it. It's going up. Now, one of the interesting things that Scheme for Macs does is it allows hot code reloading. So we can change our program while it is running. If we use reset, we wipe the interpreter. If we use reload, or just send in new messages over, say, the network using OSC, which is what this UDP receive 7000 is for, we can redefine our functions while it's playing. So for example, I have this set to, whoops, oh, I gave us the hung note. Just restart that. Okay. We are set to transpose up 1. Let's put it up to 2. Now I'm going to redefine this function and flip it around. I'll change this to a minus transpose. And I'm going to send this function over the network into the program and redefine it as it plays. There we go. We are now reflecting. I'll put it back. Now you might be wondering how I did that. Well, I have some Vim helpers and a Python script that takes whatever parenthetical expression I'm in and sends that to Python, and Python sends it over OSC into port 7000, receiving it into Macs directly. So how we do that is a little bit more of an advanced trick, and that's covered in another video on editor integration. But it's really convenient because it means I can do things like work on my program from a REPL here in a Vim window. So for example, I can say post hello world, and let's take a look over at the console, clear the console, send this over the network, and there we go. We're posting hello world. So as you can imagine, that is really convenient when you're building something complicated, to be able to redefine parts of your program as you go, and to be able to do so in a variety of ways, either from a REPL in the patch, or from messages, or from the file, or over the network. So you can also do that in the file by using the reload message, which will reload your file without wiping the interpreter. So if, for example, you had state variables in a different file, you could just reload your functions without wiping your state variables. All right, let's put this back to 0 and close this patch. Now, another major feature of Scheme for Macs, in addition to that hot code reloading, is that it runs in the high priority thread. This is unlike the JavaScript object. So that means that you can count on reliable timing. And that means you can build algorithmic composition or generative music or sequencing tools directly in Scheme for Macs. And so I'm going to display one of those. So you can't really do that in JS because the JS object is always in the low priority thread. So if you have much activity in the low priority thread, aside from your delay calls, you're going to get your timing borked. That's not the case with Scheme for Macs. All right, let's open up the next device. And we won't get into the details of exactly how this one works because it's more complicated. But what I wanted to display is that you can build sequencers and their timing is both reliable, but also easy to synchronize with the rest of Ableton Live. So we're going to open this device here. This is a random walk sequencer, and I will open its code. Its code is quite a bit larger. All right, here's our random walk sequencer. And I'm just going to take away my head so that you can see more code. Okay, there we go. That's the code. We have a sequencer that fits in 60 lines of code. And what this does is take a bank of notes, which are the pentatonic scale, and a bass note. And then on each step, it chooses one, except it has some smart choosing here. This choose note function does some filtering, so it will not play the same note it played the time before, and it's also limiting the filtering to within a major third. So I'm saying get all the candidate notes, filter out the same note we played last time, filter out any of them that are more than 4 steps away, and pick your random candidate from that. So that's sort of a generative random walk function. And then we have the function that runs on each step. So that's this run step function. We won't step through the whole thing, but it picks the note, outputs the note, updates the state variable for the last note that was playing, and then importantly, schedules its next iteration. So it's a self-scheduling sequencer. What it does is check if it's running, and if the flag for running is still going, it will put itself back onto the scheduler using the delay TQ function, which is ticks quantized. And if we're using ticks quantized, that will be quantized to the Ableton Live master clock. So it's going to stay in sync with Ableton. And then we also have just a start and a stop function and a transport listener. All right, so let's give this a listen. So the transport listener is hooked up to plug sync. That way we get a message right away from live when it starts, and that's going to call this function that I just showed you down at the bottom, set transport. That's listening to transport and then fires off our sequencer. Okay, let's make this thing go. Is it turned on? It's turned on. And there we go. We have a random walk pentatonic sequencer. Right, so I'm going to give this a stop. We can turn off Mr. Electric Piano there. Now, of course, one of the questions people have is how is it for latency? How is it for reliability? And Scheme for Macs also has controls to help you interact with the garbage collector. So in this particular case, we are deterministically running at every 300 milliseconds to make sure that we don't ever have a long stall out, and that helps us stay in sync. And the result of that is between the high priority thread and our garbage collector controls, we can use it with the rest of Ableton Live with really no issues at all. I mean, you can't have super duper low latency, but you can't really have super low latency with very many soft synths these days. So I found that really doesn't make any difference. And so to demonstrate that, I'm going to turn on these drums as well. Let's just stop that, turn them on, and we'll play. And you can hear that it's in sync with this drum track, which is just a regular old Ableton clip. Okay, here we go, no problems. And let's again display that we can update the code in real time. So, actually no, I can't display that on this one. I forgot to put a UDP receive object in this particular patch. So we're not going to do that, but suffice it to say that that is something you could do. You could redefine any of these functions. So if you wanted to, you could redefine your filter function or your run step function while it's playing. And that's something I do regularly in my larger sequencing ensembles. And to give you a sense of how well this performs, I've got larger ones that I use where I have 8 different synthesizers doing very complicated sequencing, updating real-time displays with the S4M grid object, and all running while Ableton does all kinds of other work, including lots of plugins, and it runs flawlessly. So you can definitely do real sequencing in it. All right, moving on, I'll show you one last thing, and that is using the Live API. All right, so in our final track here, we've got this one is not embedded in a subpatch, okay? And this is an example of using scheme messages to make Live API actions happen. So I will just stop this and fire a clip. There we go, clip 00. Now I can stop it. Oh, there we go, no drums. Here is stopping and starting all of Live. And here's an example of using it to manipulate a parameter. So I'm going to put the drums back on. I'll turn the synthesizer down a bit so that you can hear the drum EQ being changed by this parameter. So over in this example here, I have what a low-level call looks like. These are high-level functions, and let's just take a look at what that looks like in the code. So I'm going to open from the extras directory. Let me just get that open. The Live API scheme file, and this is part of the code. I'll make myself disappear again. So this is something that comes with Scheme for Macs. There is a low-level object for working with the Live API right here. You don't really need to learn how that works. You can if you're interested in it. And then you can make high-level live API functions that use the low-level API, and they are very nice and small. And so one of the great things about using Scheme in this context is that it's built for doing list processing, and the live API works by building symbolic lists. So you can do this kind of thing in JavaScript, but it's pretty ugly and cumbersome. Instead, let's take a look at what a fire clip function looks like. We're simply sending this path to find our clip. So this is the list, live set, tracks, our track number, clip slots, our slot number, clip, and then the message we want to send to it, which is call fire. So these are the exact symbols that you find in the live object model documentation. So here's an example using Lisp backquote syntax, which is even more concise. So we go live set, tracks, the comma means we'll use the track variable, clip slots, comma means we'll use the slot variable, clip, and then call stop. So adding your own live API functions is very straightforward. Down here we have examples of the device parameters. So the only ones I've put into this package right now are what we have here. But all you need to do is look at the live object model to make more of them. And I do plan on beefing this up so that I have more out of the box for people to use. And so if we look over here, you can see here's an example of a direct call using the low-level live API object. And then for those of you who are interested, you do need to have this live API subpatcher, although there is also a command that you can send to the Scheme for Max object that will create it for you. And that's where the guts of this live. So we've got the live path object and the live object, and they have scripting names, and they're hooked up to Scheme for Max. So that's how all of this works down there. It's using those devices and sending them messages with the Scheme for Max send function that allows you to send messages directly to anything that has a scripting name. Okay, so that gives you a very brief example of what it looks like to use Scheme for Max and the kind of things you can build. So let's just wrap up by showing you how you can find out more. So as I mentioned, downloads are on the GitHub page on the release tab. So this is right now the home page for the project. If you go here, the README below has the current rundown on the current release, links to everything you might be interested in, descriptions about the project, etc. And the release tab over on the right is where you get your downloads. So that's down here. Current release is 0.4. There is a Discourse forum. I just spun this up quite recently, thanks to the people at Discourse for the free hosting of the forum. So there's not too many people on it yet, but that is where I am putting announcements. And if you get stuck on installation or any issues and you put a post on here, I will help you out. There is also extensive online documentation for the project. So this covers the API for all the different things it does. And there is even an online ebook that I have written for you to learn the basics of Scheme. Scheme is actually a very simple language to get going in quickly. It has almost no syntax, which is part of what makes it so amazing. So if you've done, actually you don't even need to have done any programming. I've written this ebook so that if you're a brand new programmer, you're motivated, you can learn Scheme from here. There are also lots of great online resources. And then finally, there is the built-in help, which covers basically everything that Scheme for Max does. So for example, if we were to make a new device here and we were to put in an S4M object, we could open the help, and that brings up the Max help window for Scheme for Max. And this has tabs along the top that cover all the functionality of Scheme for Max. So the REPL, working with symbols, making listener functions, working with lists and messages, reading and writing to tables and buffers, dictionaries, arrays, the new S4M grid object that you can use to make tracker interfaces, working with the scheduler, and tips for performance and latency, so how you can override the default garbage collector, and also information on Max for Live. All right, that is the whirlwind tour of Scheme for Macs with Ableton Live. I hope that you come and check it out. I hope that you get in touch on the forum. If you have any issues, please let me know, and I will be linking to more Ableton Live specific videos in the future, including installation and walking through making some more complicated devices. So looking forward to hearing from you, and happy hacking.